So we left off with this idea that symmetric algorithm, if we all had the same key, that we have a problem. How do I send it to somebody? And so we said, if we did this asymmetric key, a public and a private key, that we can get around that issue. But what I didn't talk about yet is the keys themselves. And so we looked at this, we said, all right, Bob sends this and he encrypts it with Alice's public key, and then she can decrypt it with her private key. So I can encrypt with a public, decrypt with a private. I can encrypt with a private, decrypt with a public. So they work both ways. Great. So here's the part where it gets a little bit dicey. So we know we need to have that key pair. Public key doesn't need to be encrypted. The private key you want to keep safe. It's only on your computer. And the hard part is the idea that these things are related to each other. So digital signatures, we can do something similar. And that digital signature gives us that ability to say, yeah, it really was from you. And so there's this table, and this is in your book. It's also in the slides if you want to grab them. And you can actually say whose key we need to use in either one of these cases. And so I encourage you to look at it, work your way through it. But we need to know something about those keys. So we know that this asymmetric encryption, so we have a public and a private key, gives us our confidentiality. We can make sure the files have not been changed. We can make sure they're available. We can make sure they're authentic, and we can even tell what you've done with them. So we can guarantee that it actually came from you for both good and bad purposes. So how did these keys come about? You apologize to Liam? All right. So here is where it gets kind of ugly. How many of you are math majors? How many of you, when I say the word, it gets ugly, and I say math in the same sentence, you want to walk out the door? So we're going to give you, we're going to give you kind of the quick overview of how these work. So it shouldn't be a secret that that private key and that public key are related. That's how we can unencrypt when we have the private key, because they have a relationship between those two keys. They're dating. Let's just say they're dating. They have some kind of relationship between them. And so creating those, we have a lot of different methods. So MIT patented a method way back in 1983. And this one uses two very large prime numbers. What's a prime number? Do you guys remember what a prime number is? A number that only has itself as a factor, right? So we find some very large prime numbers. We can use them. We can have an algorithm. And we're not going to go into that algorithm. But there's some other ones that actually happen. So I like this term, elliptic curve cryptography. What? Do you remember all the way back in college algebra and you had to draw those ellipses? So this is another way that we can relate them, that you could think of those two values, a public and a private key, both on a point on a curve. So if I had that formula for that curve, I could do that. And so in some cases, this gives you a little quicker curve. So you have something like this. You guys remember those formulas for those kinds of fun things? You're like, nope. In fact, I saw somebody's head just explode when they looked at that. But what we're looking at is there's a relationship, and we can do that. So it can lead to some quicker computations. Let's just say that. So there's all different other kinds of ones. So lattice-based cryptography. Holy cow, what are we talking about here? Just remember there's other ones. There's quantum cryptography. Oh, man. So how many of you are quantum mechanic physicists? Yeah, me either. So this is where it gets really freaky and weird, but we know that sometimes subatomic particles do some odd and interesting things, and we can actually use those properties to create those pairs of keys. So we kind of went right through there, right? Was that quick enough? You need to know how they come about. You don't need to know the mechanics of how it works. If I can remember you have a private and a public key, how they arrive is probably less important, okay? We know that we need to use the private key. And so we're going to kind of give you the key exchange thing very quickly too. So what I want you to know is that there's out-of-band and inbound. So out-of-band means alternative to my communication. So outside of email, somehow I send you that key. Inbound means I put it in the same communications channel. And so there's advantages and disadvantages to both. We're going to jump right through here and jump to this slide, because I think this is where it becomes important. Why do we care about cryptography? Why do we care? So the bunnies and the rabbits and the happy flowers tell us we need to come up with some way that we can protect our data. And we can do it in cryptography. We don't need to know all the mechanics behind the scenes. You don't need to be the mathematician finding those prime numbers and figuring out a formula or an algorithm to do that. We're going to show you what is out there that you can actually use right now, and you can use it on your own computers and hardware. So I want to point out this piece, that cryptography can be either hardware or software. So if I did it in hardware, what would be the advantage to having my cryptography in hardware? So if every computer had a cryptography chip on it, what's the advantage to that? Is there an advantage? Why might it be an advantage? Would it maybe process and do that encryption faster in hardware? There you go. So software, though, gives us the advantage. It's portable. It moves from device to device. So in theory, if I encrypted my hard drive on my laptop that had built-in hardware encryption, and I destroyed the computer but the hard drive was still there, there is no way I can ever get that information back. And so that may be good unless I didn't have it backed up. So there's some other advantages with that. So we're going to look at a couple of them. And this is where we can look at something kind of interesting. So in software, we can encrypt almost any device you have. Everything from your flash drive. You can actually use an encryption program. You can use your desktop computer, and you can encrypt every file on your computer. Is that a good idea? Actually, it might not be a bad idea. So for those of you that are involved in activities that are, say, not legal. Is anybody involved in here in any kind of banking scheme, fraud, child pornography? All right, so you don't want the FBI to get your files, right? You can actually encrypt them with several tools. PGP is one. You can actually go out and download it. It's free. There's another one called TrueCrypt, and there's several others. You can encrypt those files, and the FBI, NSA cannot find them right now and get to them. So that's both good and bad. If I'm a business and I have business secrets, and most businesses have some form of secret, I can also encrypt that data. Or not necessarily secrets, but information I don't want shared with the world, like Social Security numbers of all my clients. I can use these encryption tools to do that. So these are a couple we actually have built right into Windows. You can actually use an encrypted file in Windows. And Windows can actually do this really, really well. It's one of the great advantages. Except you can't do it on the home version of Windows, because Microsoft says that's one of the differences between the home and the professional versions. But their file system is capable of encrypting the entire hard drive if we wanted to. Probably not a bad idea for a lot of businesses. Because if you lose a laptop and it's encrypted, you don't have to go through that whole rigmarole of saying, oh, you know what? I lost all the customers and their Social Security numbers and their medical billing data. And so we've lost, with losing things like laptops, huge amounts of data. And so one of the ways we can get around that is things like encryption. And whole disk encryption, we take that entire hard drive full of data. So from the minute that computer starts up, everything on that drive is encrypted. And more customers are requesting it. More and more hardware vendors are supplying that. Now, You're not going to get this on the computer you go buy at Best Buy for your house. But if I go to Dell, or I go to HP, or I go to Lenovo, I buy a computer for a business, I can get whole disk encryption. One way I can also do that is through BitLocker, which again is a feature that is in Windows, but only the professional version. So BitLocker, we encrypt the entire drive right from the get-go. It's not a bad thing to do. So, a couple of reasons why we might want to think about a hardware version. So, hardware in theory can be even more secure because it's embedded directly. It can be faster because we have that embedded and we don't have to run through the operating system. So, there are a lot of laptops, for example, you can purchase that have a hardware encrypted hard drive. You can buy a USB drive that is hardware encrypted. You can also run a software piece on it. And it is significantly faster and significantly tougher. Many of the hardware USB drives, if you get the combination wrong or the password wrong a couple of times, that hardware says, whoop, we're wiping the drive. And they will do that automatically. The software ones are probably a little less resilient. So hardware and software are both good. So those USB drives we all have, heck, I've probably got 3 of them in my pocket right now. We can store a lot of data in these, right? They're pretty scary, though. I could do a lot of other damage with them. So the hardware versions, are a really, really great idea for a lot of businesses. So any business that does data and puts them on here, and it's data that's important, those encrypted ones, they usually have a little bigger case. Some of them even have a thumbprint and other things. So we can remotely control them. We can turn them off. So any business, like a medical business, here at our college, if somebody in financial aid is backing up stuff on a USB drive, I hope that they're using an encrypted drive. That way that information doesn't get lost. They're not that much more expensive now. They're pretty cheap. Same way with hard drives. We can buy them that encrypt automatically. So, and again, we have that ability. If it fails, it can actually wipe the drive or change the key so that nobody can ever get it. Ever. And the keys we have are big enough now that in 20 years from now, the NSA may be able to get your data, but probably not today. Not necessarily a bad thing. And again, it does present a little bit of an ethical issue, though. Do you think the FBI and NSA would like to be able to get to all of your hard drives? Because, for that porn kingdom that you're creating, they would like to be able to get in there and look at those files. But right now, they don't have the processing capability to get in there. Now, if you put a really weak password in there, sure, you might be able to. So, we also have the idea of something called a trusted platform module. And that's actually a chip right on the computer that does those crypto services. And one of the keys to that is that it creates a true random number. So the computer can give us what they call as a random number, but because they're all generated the same way and from the same seed, a lot of times we can guess what those random numbers to begin with. And if I know what that number you're starting with when you start doing your encryption, I can break your encryption. So they have a special chip for random numbers. They have a special chip. Everything is in hardware. So we can lock you out of that entire computer. So not only encrypting the drive, but you can't even sign on to it to get onto the network in some cases. So we're making computers more secure in the business world and for those businesses that are willing to purchase them. So the program that I really like, if you will open up a browser window, and if you will type in TrueCrypt, this is the one that I used to prefer. Now here's the problem. When was its last release? Oop. Apparently it's moved its website. So, is that one truly probably safe anymore? No. So again, part of this class and part of what I want you to look at is what was safe and practices done even 2 years ago, 3 years ago, is that safe? So my guess is the stuff that I have encrypted with TrueCrypt, somebody could break now. There are computers powerful enough to break these software pieces that we have. So unfortunately, these tend to go in and out. So there are some other ones that are out there now that are fairly affordable. I used to use TrueCrypt a lot encrypting flash drives because I was really bad about leaving flash drives laying around, and it had things like all the quiz answers. And people might want that. Didn't have anything really exciting other than quiz answers. So, and in fact, there's probably quiz answers out floating around on the flash drive in my pocket if you want to mug me. Maybe not. I'm not sure what's in there. So, make sure you do both discussion boards and you have this open puff experiment. And so we left open puff. We had encrypted a document, right? So now we need to figure out how to get that information back out. And I showed you the two files. Those pictures look identical. So I'm going to open this back up. I'm going to close out of here. Chunk. Close this out. And I'm going to open wherever I put open puff. Hang on. Somewhere I put it. Chunk. Unless somebody took it off my computer, which would be interesting. Lucky enough I found it. So remember, it doesn't install necessarily, it just, we need to extract it. So now I have my program back open. And before we used it to hide it. Well, now we want to unhide. So I have to remember a couple of things. I have to remember where I put the file that I hid the document in. And so I think I put it on the desktop. So let's find it and see if that's true. So desktop, I should have had a picture called the All College Photo. And so it went through and checked that. But the other piece I need, and this is why I said to write it down, I need all three of those passwords to that protected document. So in this case, I have my first password, and I handily wrote them down. And I have my third password. So I have all three passwords. And notice now it turned green. It said, hey, you found the right password. I've got the carrier. I'm going to click unhide. And it's going to ask, where do I want to put the document that I'm extracting out of there? So this is my message document. And remember, I used a text file. And so just so I know where it's at, I'm going to throw it in the music folder so I know it's in a different spot. And it's unprocessing, processing, processing. And so now I'm going to look and go see if in my music folder, if that document does exist. So music I know doesn't have much in it, except it took out my text file that says this is my secret message. So it was hiding in that picture the whole time. So we could hide an entire message, we could hide plans, we could hide instructions, all kinds of things inside of a simple picture. So this OpenPuff, if you don't have those three passwords, you're not going to find the information in there. It actually does a really, really good job of hiding it inside of there. So I'm going to go through this again. I'm going to make a new message. So I'm going to use Notepad because, again, I'm just making a text message. And I'm going to have a little longer message. This is my secret. Please don't forget to do the discussion board and the extra credit. Discussion board. The weather is really nice out today. We should play golf. If I can type. All right, so I've created a message. I'm going to save that, and I'm going to save as, and I'm going to tuck it in my documents again, and I'm going to call it my next secret message. So I've saved it. Well, I need another picture because I don't have a ton of pictures on here. So I'm going to go to Google, and I am going to search for a family photo. Not of my own family, because nobody wants to see that, but here's a cute, wonderful family picture. And I am going to save this picture. I'm not sure where it's saved at now, so I may have to do a double check on that, but I want to save image as, and I'm going to put it in my photos, and I'm going to call it family picture. So I just got a brand new picture. I'm going to send this to people because, great, it's hiding in there. So I'm now going to take OpenPuff, and I'm going to close it out. I'm going to hide. So again, I already have 3 passwords, and I'm going to use the same ones just because I have them written down and I don't want to do that again. So I have 3 passwords. They all meet the requirements. I am going to put this picture, so I'm going to add, and I'm going to go to Photos, and I'm going to add my family picture. But I'm going to make it a little tougher this time. It's going to add that one. Slowly but surely. So, and we can add different, we could have put this inside of a song or any other medium we wanted to. Apparently I picked a very big picture. Or I have the world's slowest computer, one of the two. So, now my picture's added. But I'm going to see if I can put that file inside of there. And so I'm going to go to Documents, and just to see what happens, I am going to actually grab a Word document or something a little bigger, because it doesn't have to be just a text document. So I'm going to try to add a PowerPoint inside of there, and let's see what happens. And when I do that, notice this turns red. And the reason it's red is we don't have enough hiding spots inside of that one picture to do that. So maybe if I add a second picture, and I can spread it over more than one item. So to make it even harder, I'm now going to put it into multiple pictures. But look at that, I still don't have enough room. I think I have one more picture in there I can use. Not sure what that is, but we know that we've used all 3 pictures, and it's still angry at me. So in this case, I need to figure out a way to either make my message smaller or my pictures larger or more of them. So I'm going to go back to Browse, and I'm going to grab what I really want, my next secret message. And I'm going to take out those pictures, and I'm going to go back and add just that family picture. And it'll take it a second to add it in again. And I feel like I hear the Jeopardy music playing. It should only take a little bit. Go on. Ah, there it's gone. All right, and so now, notice it turned green. It says, yep, I have enough spaces in there that I can hide your entire message. And so I'm going to click hide. And when I do that, this output directory it's going to say, where do I want to put that picture? Well, I'm going to put it on the desktop. So I know I have a second spot, and it's going to hide those two items together. So, and again, the faster your computer, the faster this works. And I know some of yours at home, some of yours in the lab are significantly faster than this poor thing. And 3, 2, not yet 1. So, how about those Dodgers? So, again, this is actually very computationally intensive, so it does take a while to do. Ah, there we go. All right, so I have now put that family picture. So it tells me all about it. And that family picture is over here. I could email that family picture to somebody, and now they could get that message. Or I could post it to Facebook, and somebody could pull that down. Or I could send it on Instagram or any of other of these alternative channels. You don't know just looking at it that there's anything special about that picture at all. It looks like a great, cute family with a couple of kids missing some teeth. No idea that it's in there. But I'm going to go back in and see if I can pull that back out again. Just so you guys don't think I created this ahead of time or anything. So here's my family picture. I'm going to close the box to hide, and I'm going to click the unhide. So again, I have to put in my 3 passwords. I have to find where that picture is, and I know it's on my desktop. Happens to be desktop. And somewhere in there is a picture. Family picture. So I'm adding that back in. So it's searching through that. Meanwhile, we can take a nap while it's doing that. Aha. So then I click the phrase unhide. Because I've got my 3 keys, and I know that it's in there. I haven't selected, and you'll notice over here there's different types of ways to hide it. I just went with all the defaults, so now I'm going to click on hide. It's going to ask me where I want it. I'm going to put that file on my desktop. So now my secret agent has sent me a message. I'm unencrypting it out of an image he sent me, showing me his family off on vacation. And it calculates. And so now, over here on my desktop somewhere, task stop corrupt stream. I must have made some kind of an error, probably put in the wrong password or something odd. And so it says, nope, you didn't get that. So it takes a little bit to do, so I'm just going to go over here and show you this one, which I did earlier, is the one I did. I'm sure what I did was type a password wrong, and it just pops up and saves that file. And it would do the same thing. I might run it really quickly and see if it will. Let's see if it'll unhide it from that. My guess is that I fumble fingered, and I may have done it when I created it and typed the wrong password, in which case there's no way to retrieve that particular document. I could always recreate it, but that takes a little bit. So this is a tool you guys could use to hide almost anything. You send your family picture, and in the background you're hiding the new keys to your house, or where you're hiding your Bitcoin wallet, or whatever it is you happen to have that you need to hide. And so, why does it not want to click unhide? On the desktop, we'll see if it hiccups this time. So, what we've done is figured out a way we can encrypt our data, hide it inside of a picture, and send it to somebody. Surely nobody would ever use that for malicious purposes, right? And it's out here on the... Oop, now in hiding. I do like how it stays at 0% and then all of a sudden it pops and says it's done. On other machines I've used it on, it actually does have an increment bar. So it's probably straining this poor thing. Aha! It actually worked that time. So I did type something wrong and it pops up over on my desktop. And it actually says, I pulled out 188 bytes. And there's my secret message I buried in there. But it doesn't have to be that innocuous. And so what we've figured out, and we think, in a lot of cases, terrorist groups are being able to send images and videos and other things buried inside of other objects. So this is a way we can get around it, but there are probably legitimate business purposes for this, right? Maybe. It's a way to obfuscate my data. All right, so if you haven't done this assignment, you are certainly welcome to do it here in the lab. Remember, you have to extract that entire folder from OpenPuff. So you can't just try to run the program without it. So you download and extract that entire folder because it's got a couple of libraries of information that we need in there. So it's an interesting project.